Okay, welcome. I'm going to try to get through these notes. Make sure you have them ready for you. We're going to classify triangles. Today you will identify and classify triangles by angle measures and side measures, and you're going to use this to help you find like maybe angle measures and side measures or different properties to use that. So we'll kind of go from there. So let's see here. Let's go to the next part, okay? So how can we classify them by angles? We have an acute angle, which would be acute triangle, which has 3 acute angles. Equilateral angular triangle, which has 3 congruent acute angles. You have an obtuse triangle, which has 1 obtuse angle. Notice that this one only, for the obtuse, you only need 1 obtuse, and for right, you only need 1 right. Okay, so what does that mean? Well, let's look. See, if I gave you something like this, what would you call that? Well, you would call that an acute because all 3 angles are acute. How about this one? Well, because of the 90 degrees, you would call that one a right triangle. And then this one, because of the 97 degrees, you would call it an obtuse triangle. Okay, so you can see there's not that much to it. It's just basically look at the angles, try to find the one that fits the best, and then go from there. Alright, now, what about something like this? What if I were to ask you, what is PQR? Well, because of the segment addition postulate, not segment addition, the angle addition postulate, this one is obtuse. And the reason, again, like I said, it's because of the angle addition postulate, which allows me to add 45 and 59, which is going to add up to more than 90 degrees. So that angle right there, that is PQR, because you're looking at the whole big thing, you're looking at this whole big thing, so this angle right here is going to be bigger than, say, 90 degrees, so this would be an obtuse triangle. Alright, so how about if I have to classify them by their sides? Well, if I classify them by their sides, I have equilateral triangles, which has 3 congruent sides, isosceles, which has 2 congruent sides, at least 2, what? Anyways, and a scalene triangle, which has no congruent sides. So either you have equilaterals, isosceles, or a scalene, depending on how it goes. Oh, I like how they point out an equilateral triangle is a special kind of isosceles triangle. Whatever. Okay. Anyways, let's look at an example here. Alright, so what if I were to give you something like this and tell you that M is the midpoint of JL, classify JKM. Okay, so M is the midpoint of JL, then technically that means that JM is congruent to ML by definition of the midpoint. Okay, and then, I'm just going to do this as a proof. JM plus ML must equal JL, and we now know that that's equal to, JL is equal to 1.5, and ML, and since JM and ML are the same, I can put ML in its place. Probably could have done JM. I don't know why this one. I'm following the book, and so they decided to do things funky. Anyways, by substitution, and then you can do some like just basic properties. Combine your like terms, that's simplifying, or add addition property, and then divide by the division property, and you get ML is equal to 0.75. If ML is 0.75, then so is JM by definition of midpoint, and then KM, because KM and ML were already equal. So, since JM and KM and even JK are all the same, they're all going to be 0.75 because we've already got this 0.75 for JK, then the whole thing is an equilateral triangle, or JKM is an equilateral triangle. And that's really about it. What happens if we had one that was like, say, an isosceles triangle, and let me give you one more example and then I'll be done. Okay, so what would happen here if you had, like, say something like this and they were wanting you to find like the length of the side or the x? I mean, there's so many different ways I can ask this question. Well, first off, notice these two sides are congruent. So then that means you're setting those two equal to each other. So 4x plus 1 is equal to 5x minus 0.5. Variables to the left, numbers to the right. So I'm going to say minus 5x, and I'm going to say minus 1. 4 minus 5 is negative 1x. And then negative 0.5 minus 1 is negative 1.5. Divide by the 1, and you get x is equal to 1.5. I'm sorry, divide by the negative 1. Okay, so that one's equal to 1.5. Now, from there I can plug, so I now know what x is. I can plug that into any one of these two. Let's say 4 times 1.5 plus 1. And 4 times 1.5 should be 6. 6 plus 1 is 7. So this length measure right here is 7. And then if you do that, this one should also be 7. Okay, so now I know that they're both 7. And then if I look at the next one, this one is 9 times 1.5 minus 1, and you should get, I believe, 12.5. So you can find all the measures of the sides of the measures of the triangle. You can also see that, well, obviously based on just these congruent marks, this is an isosceles triangle. But you can find x, you can find the length of the sides. Just depends on what you need to do. Anyways, that's it for today. I'm going to say stop right there. Thank you so much for your time. Hope y'all are doing well, and I will see y'all later. Thank you. Take care.